This is lesson 12-3 and this is part 2. And in part 2 we're going to talk about a pretty important and very useful topic called the law of sines. And so hopefully up until this point in time in your trigonometry life, you have been looking at triangles that are right triangles only. And this was a big problem for mathematicians because although right triangles were extremely useful, not every single triangle in the world is a right triangle. So it became a quest to try and find out how you can use trigonometry in triangles that are not right triangles. And so this is your first introduction to that way of using trigonometry in triangles that are not right triangles. So today we're going to look at something called the law of sines. We're going to use a triangle like this. Remember that angle A, side A, angle C, side C, angle B, side B. Alright, and then I also have the height drawn in, which remember is that perpendicular segment from an angle to the opposite side. So that's labeled H here. So if you take a look at this triangle right here, and let's focus on, let's start with angle C. Alright, if we wanted to talk about the height right here, and then we're going to focus on angle C. So let's write focus on C. The height of this is the opposite side in this right triangle from angle C, and the other side that we have here is side A, and that would be the hypotenuse in this right triangle that the height makes. So I could say, because sine is opposite over hypotenuse, the sine of C equals the height of the triangle over the length of side A. So let's change our focus real quick here, and let's focus on angle A. Let's see, focus on angle A. This time, here's our angle. This is the opposite side, the height is, and in this right triangle right here, C now is the hypotenuse in this right triangle on this side. So let's see, if we're looking for the height, we could say the sine of angle A equals the opposite side, which is H, over the hypotenuse, which is C. So in both of these cases now, I'm just going to use some algebraic rules, and I'm going to solve those equations for H. So if I do that over here, I put this over 1, I'm going to cross multiply. H times 1 is H, and then sine A times C, side C. Over here on the right hand side, if I put this over 1, H times 1 is H, and sine C times A is sine CA. Now, what do you notice, and this is the aha moment, what do you notice about what this is equal to? Well, that's equal to H, and take a look at this. Hey, look at that, that's equal to H. So doesn't it make sense then that we could set them equal to each other? So the sine of A times C equals the sine of C times A. So now I'm just going to do one more algebraic trick here. Since both of these are being multiplied by A over here and by C over here, let's divide both sides by AC. Over here, C divided by C makes 1, and A divided by A makes 1. So what are we left with? We are left with sine of A over A equals the sine of C over C. So look at that. Sine of A over side A equals the sine of angle C over C. And this works every single time. So this is called the law of sines. I could take the exact same triangle, I could draw in the altitude or the height from angle C now, and I could do the same thing with angle B and angle A. So what you need to do is you need to write down in your notes the law law of sines. And the law of sines says the sine of angle A in a triangle over the length of side A equals the sine of angle B over side B equals the sine of angle C over side C. So make sure you get that formula written down. We're going to look at two different examples of how you can use this. So when you come across a problem like this, the first thing you want to do is ask yourself, is it a right triangle or not? If it's not a right triangle, then you can use the law of sines. And what you need to cue into, what you need to look for is this. Do you have an angle and its opposite side? An angle and its opposite side. That's how you cue in and say, oh, okay, this is a law of sines. Angle, opposite side, angle, opposite side. So let's talk about how you use the law of sines to find this side length right here. So here we have an angle, the sine of an angle over its opposite side. So the sine of 59 degrees over its opposite side has to equal the sine of an angle over its opposite side. And so what you can do now is you can just use a calculator and you can just do, I'm going to cross multiply, so sine of 38 times 350 is, let's see, sine of 59 times b equals 215.48. And now I divide both sides by the sine of 59. So I'm going to divide by the sine of 59. And b, side b, has a length of 251.39 centimeters. Alright, so there you have the law of sines and finding a side length. Let's see if